I want to take an example first of uniform acceleration and then I'll define it. Okay, look at this is a body which is moving in this direction. It is moving in this direction and it is moving in such a way that let's say first it is at rest and that's why its velocity is 0 meter per second, but at the end of 1 second, let's say its velocity is 2 meter per second. At the end of second its velocity is, let's say, 4 meter per second, and at the end of another 1 second its velocity is 6 meter per second, and so on. Looking at this figure, looking at this motion, what can we understand? In 1 second, its velocity, increase of its velocity is 2 meter per second. This minus this. In another 1 second, the increase of velocity is again 2 meter per second. Another 1 second, increase of velocity is 2 meter per second. What it mean? It means in equal interval of time, the change of velocity is same. It is moving in such a way that its velocity changes in equal amounts in equal interval of time. And if we see these figures, I mean to say these values, then we can understand easily that the change of velocity is 2 meter per second in every 1 second. And if we calculate its acceleration, then what comes? Acceleration is equal to final velocity, this one, initial velocity, this one, final velocity v minus initial velocity u, divided by time taken to go from this 0 meter per second to 6 meter per second, 1 second, 2 second, 3 second, 3 second. This is time taken, and v is 6 meter per second, u is 0 meter per second, and time taken is 3 second. And this is equal to 6 meter per second divided by 3 second, 3 1s are 3, 3 2s are 6. This is equal to 2 meter per second square. Therefore, acceleration is how much? 2 meter per second square. Okay. Now, I want to give you another example also. Instead of increasing velocity, sometimes what happens? A body is moving. It has certain velocity. Let's say its velocity is 20 meter per second at the beginning because it is moving, and after 1 second, if its velocity decreases to 15 meter per second, because let's say force is applied in the opposite direction, here force is applied in this direction of motion, here force is applied in the opposite direction, and in 1 second, first it was at this position 0 second. At the end of 1 second, its velocity decreased and came down to 15 meter per second, and again on another 1 second, let's say at the end of 2 seconds, its velocity gone down to 10 meter per second, and another 1 second, its velocity gone down to 5 meter per second, and finally came to rest 0 meter per second. In this case also, look at 1 second. I mean to say, in first 1 second, its change of velocity is 15 minus 20. 15 minus 20 means minus 5. In the same way, another 1 second, 10 minus 15 means minus 5. Again, here also minus 5, here also minus 5. If you want to calculate it by using formula A equal to V minus U by T, final velocity here, initial velocity is this, and time taken is from this to this. That's why this is equal to V is 0 meter per second, U is 20 meter per second, and time taken to go from this to this is 1 2 3 4 seconds. Now this is equal to minus 20 meter per second upon 4 second, and here 4 1s are 4, 4 5s are 20. That's why its acceleration is 5 meter per second square. This is the calculation of acceleration. It came negative, it came positive. Whatever it is. Now, how can we define uniform acceleration? Both of them are moving with uniform acceleration. A body is said to be moving with uniform acceleration if its velocity changes in equal amounts in equal interval of time. Look at this. In this case also, change of velocity in every 1 second is 2 meter per second. In this case, change of velocity in every 1 second is minus 5 meter per second. In equal interval of time, change of velocity is equal in this case also, in this case also. That's why in both the cases, the body is moving with uniform acceleration. Okay, this much for today.